So the liver synthesizes a protein called albumin. And what albumin does for us is it carries all the molecules in metals, in anything that's insoluble in blood. Albumin carries all these insoluble aspects for us through blood. So again, albumin is used to carry insoluble molecules in blood. So molecules that are insoluble in blood, albumin carries it for us. Alright, which includes thyroid hormones, sex hormones, cholesterol, steroids, vitamin A, B6 in these metals, bilirubin, transferrin, which is a protein that carries iron, and fatty acids. So all these are insoluble in blood. Albumin is the vehicle that carries all these things through the blood for us. And this is just a partial list. So albumin is incredibly crucial for us to function correctly. So because just getting the thyroid hormone to where it needs to go in the body is incredibly important. It's insoluble in blood, so we need albumin to do that for us. So again, albumin is a protein that's synthesized in the liver, and it has a functional group or a prosthetic group called hemin. Now hemin is made up of a porphyrin ring, which I went over in the liver part 2. And here again are the vitamins and minerals that I found that we need to make porphyrin with. As well as these vitamins and minerals, hemin also requires a chloride atom. Now, our RDA for chloride is actually 3.6 grams, which is, in my opinion, a little bit, is a lot. So you want to make sure that you're getting enough chloride in your diet to allow hemin to work correctly, as well as to help maintain a blood pH, because chloride helps maintain the acid-base balance in our body. So having the right pH is going to allow albumin to function properly. Okay, so what albumin also does is it carries drugs through our body. So albumin, like non-specifically, just carries drugs as well as all these insoluble components over here on the right. So it's very non-specific. So it carries actually a lot of prescription drugs through the body as well. And a lot of the side effects that people experience using their medications could be rooted in the fact that they are binding to albumin. So think of albumin as like a bus. When the albumin molecule is full, it will not allow any other binding opportunities. So if you are taking warfarin or you're taking naproxen, and the naproxen or warfarin are completely saturated, the albumin, it's not going to allow these thyroid hormones, sex hormones on the bus. The albumin will not be able to bind to all these things on the right side of the board here. And that can cause a lot of problems, a lot of systemic symptoms. And again, albumin binds to drugs non-specifically, so it can bind to a lot of different drugs. So if you are going on prescription medications, be cautious or cognizant that they could be binding to your albumin, and it may down the line start causing some symptoms that you didn't initially experience. Now THC also is likely to bind to albumin because it is an oil. So basically anything that's fat soluble or acidic is likely to bind to albumin. Okay, so one more thing before I end here is that fatty acids, again, also are insoluble in blood. They also bind to albumin, and this is a case in point. So if we have these drugs, or if you're not producing the optimum amount of albumin and you start having these free fatty acids enter into your bloodstream, they will form something called a micelles. And a micelles is when you have the hydrophobic tails, these are in the black, these are the hydrophobic tails, and the acidic heads spontaneously start clumping together, where the fatty portion of the fatty acid will all congregate in the center, and the acid portion will all cover the surface of these micelle balls. And what they act as, they're like little balls that just bounce around inside the circulatory system, and they actually are toxic to membrane proteins in the blood. So again, if you if your albumin is completely saturated with other things binding to it and you keep producing fatty acids and they leach into the blood, you can form these micelles and they will become toxic to membrane proteins. And again, if your albumin is not at optimum levels, or it's pushing too many drugs through your body, none of these molecules on the right side are going to bind with enough regularity to be able to perform, their function in the body, and you're going to have other issues. So make sure that you try to get off drugs as soon as you get on them. Prescription drugs, try to work on getting off them safely. Make sure that you're getting enough of the vitamins and minerals you need to make the porphyrins for the hemin, and make sure you're getting enough chloride. That's celery, Celtic sea salt, seafood, and you really want to focus on making sure you're getting enough chloride.